Hi, everyone. I just wanted to give you some examples to work from while you're doing your homework examples tonight on how to solve by factoring. So I'll go through a couple of different types of examples using some different techniques. Um, the first thing that you always want to make sure that when you're solving a quadratic equation by factoring is that one side of your equation is always equal to 0. So in our first example, I have this equation x squared plus 7x is equal to 0. So once I have an equals to 0, then I can start thinking about what I need to do to factor whatever the terms are on the other side of that equal sign. So once I have one side equal to 0, the first thing that I should be looking for over here is always look for a GCF first. So in this case, my x squared plus 7x has a GCF of x that I'm going to go ahead and factor out. So that's going to leave me with an x times an x plus 7. And then I want to bring down my equals to 0. And in this case, I don't have anything left to do on the inside of the parentheses here. I can't really do much with the x plus 7. So then I'm going to use the zero product property that's going to tell me that I want to separate out this first factor, which is just x. I'm going to set that factor equal to 0. And I'm also going to take my other factor of x plus 7 and set that equal to 0. And then I want to, if I need to, solve both of these equations for x. In this case, I already know that this x is by itself, so I don't have to do any additional solving. But over here, I will want to subtract 7 from both sides of the equation to get an x value of negative 7. So my two solutions of this quadratic equation would be x is equal to 0 or x is equal to negative 7. Sometimes you might see the solution set written in a set of brackets. Usually when we do that, we list them in numerical order. So I'd put the negative 7 first and then comma the 0. All right, the second equation, this one does not have an equals to 0 on one side of the equation. So what I'm going to have to do first is I'm going to have to move something. Usually when I see that my x squared term is positive, I like to leave that where it is. And that means that I would want to bring over any other terms to the side where my positive x squared is already happening. So in this case, I would want to bring the 72 over to the other side by subtraction. So this is going to tell me that when I move that, 2x squared minus 72 would be equal to 0. Once I have that side equal to 0, then I want to look for a GCF over here, which again, I do have one. These two numbers share a factor of 2 that I'll go ahead and factor out. And that will leave me with a 2 times x squared minus 36 is equal to 0. And if I'm factoring this, I'm going to go ahead and see, well, can I do anything on the inside of these parentheses? In this case, I can. This is our difference of two squares factoring pattern. X squared is a perfect square, 36 is a perfect square. There's a minus in between. So I'm going to go ahead and write out the factors to be an x minus 6 and an x plus 6. And then I want to go ahead and solve this. Once I've got that all completely factored out, this is where I can go ahead and solve. But before I do the zero product property, because I have a coefficient of 2 out front, if this is just a constant number, in order to use the zero product property, you would want to go ahead and divide out that constant on both sides. Because over here, the 2's end up canceling out. And then over here, 0 divided by 2 just still leaves us with a 0. So then once I get rid of that 2 that's out in front, this is where I can go ahead and use a zero product property. So I'm going to take the x minus 6, set that factor equal to 0, x plus 6, set that factor equal to 0, and then go ahead and solve each one of these. So if you add 6 over here, first possible value is a positive 6, subtract 6 over here, your x value would be a negative 6. So again, you can just leave your solutions like this. If you did want to write it in the brackets, we would want to list it as a negative 6 first and a positive 6 second in numerical order. All right, so then we get into some trinomials. So what if I wanted to give you this quadratic, x squared plus 3x minus 40 is equal to 0, and we want to solve by factoring? Well, in this case, this is where I'd want to, well, first check to make sure that one side is equal to 0, which it is. So then I'm going to look and factor this trinomial. So I'm looking for factors of negative 40 that add to positive 3. I believe that will give me a positive 8 and a negative 5. So my factors would be an x plus 8 and an x minus 5. Here I don't have any coefficients on the outside that I have to deal with, so I can just go straight into my zero product property. So x plus 8 is going to equal 0, and x minus 5 is going to equal 0. Over here, I'll subtract 8 to solve for x. So this is going to give me an x value of negative 8. Over here, I'll add 5, and this will give me an x value of positive 5. So my x values are negative 8 and positive 5, or if you prefer to write them in the brackets, negative 8, comma 5. All right, so the last one is a little bit different because now, again, we don't have one side equal to 0, so I want to move some terms. I'm noticing that this x squared term, again, is positive over here, so that means that I'm going to move all the stuff on the right-hand side over to the left-hand side. So I'll do that by addition. So if I add 11x, and then I add a 6, this is going to give me a quadratic that now says 3x squared plus 11x plus 6 is going to be equal to 0. I want to look for a GCF over here. I don't have a GCF because I know that 3 and 6 share a common factor, but 11 does not. So this is where I can do one of two things. I can do my guess and check method, which this 3 is a prime number. So I know that when I open up my parentheses, the only possible combination to get a 3x squared would be to have a 3x in one parenthesis and an x in the other. And then I would want to play around with the factors of 6 to see if I can kind of place them to make sure that my middle terms add up to 11. I believe that would be a plus 3 over here, and that would be a plus 2 over here. Because if I pull that back out, 3x squared plus 9x plus 2x plus 6 would give me my original. If you wanted to do the factor by grouping method, that would mean that you would want to multiply the a times the c, which will give us 18. Factors of 18 that would add to 11 would be positive 9 and positive 2. If we do the factoring by grouping, bring down the 3x squared, bring down the plus 6, and we'd want to group these two terms accordingly with the numbers that would have a common factor. So I'll group the plus 9x over here, and I'll group the plus 2x over here. And then I'm just going ahead and grouping these terms together and looking for their GCF. So GCF between 3x squared and 9x would be 3x. I'd be left with an x plus 3. Bring down the plus in the middle. GCF between 2 and 6 would be 2. I'd be left with an x plus 3. And then my common factor here is an x plus 3. And the stuff that's left over on the outside here would be 3x plus 2. So regardless of which method you end up using, the factor should be the same, an x plus 3 and a 3x plus 2. And again, remember that when you're solving, you want to make sure to pull down the equals to 0 in each one of your steps. So then once we have this factored out, I'm going to go ahead and since there's no coefficient or no constant on the outside, I'm going to pull them apart to use my zero product. So 3x plus 2 is equal to 0, and x plus 3 is equal to 0. Get rid of the 2 over here. So that's going to leave you with 3x is equal to negative 2. Divide by 3. Our x value over here would be negative 2/3. And then over here, go ahead and subtract 3, and that will leave me with an x value of negative 3. Or if you prefer to use the curly brackets, that would be negative 3, comma, negative 2/3. All right, so I hope this helps on your homework. Let me know if you have any questions.